In this video, I just want to go over some terminology, some rules, some properties for both exponents and logarithmic functions. We need to be able to talk the terminology and understand what we're talking about. I'm going to be switching back and forth between this worksheet and just a sheet that I'll be writing on. You can find this sheet of rules under section 4.3 in your class notes. An exponential function is a problem such as y equals b to the x. Now, for example, our algebraic functions look something like y equal x squared, where this base was a variable. Now we're going to look at an exponential function, and it'll look like this, where our base number will be a number. Now it tells you here in the rules that the base has to be positive, greater than 0, and it can't equal 1. Now there are some rules, some properties for exponents that exactly mirror the properties that you had in algebra. There are 9 properties here. Some of them you'll use more than others, but I'm just going to touch on some of these properties, and you see the sheet where I'm getting these. One property that we use a lot is something like this. If I have 2 to the x times 2 to the 5th, remember, if your bases are the same, you add your exponents. It doesn't matter that that base is a number. Now, we're not multiplying 2 times 2 and getting 4. We're taking 2 to a power and multiplying it by 2 to a power. Property 2 deals with division. If I have 2 to the x divided by 2 to the 5th, remember, if your bases are alike and you're dividing, then you subtract exponents. So that would be 2 to the x minus 5. Now, one property that we use a lot in this section is something like this. You remember that if you have a base with an exponent that has an exponent, or a base with a power raised to a power, you're going to multiply. So this would be base 2 raised to the 4 times x power. Now those 3 rules are the very same rules that you had in your rules for exponential functions. There are some others that we'll use some. One in particular says that if I have 1 over 3 to the negative 2 power, if you switch positions, in other words, switch from denominator to numerator, then the exponent becomes positive. Now that can go either way. A negative in the denominator is positive in the numerator, or in the numerator it becomes negative in the denominator. There's another rule that says if you have an expression, anything raised to the 0 power, then that's going to equal the number 1. You're going to see that a lot, and you do need to remember that. If you have an expression, let's say a raised to the 1/2 power, that's the same as the square root of a. That denominator being the root and the numerator being the power. So let's say we have a raised to the 2/5 power. Now remember, the denominator is the root, so that's the 5th root of a squared. Remember, that's the power, and this is the root. Now you're going to use that in the lesson that we're going to have in this section, so you need to know that if I have the square root of x, that's the same as x to the 1/2 power. There are some properties for logarithms, and I know we haven't talked much about logarithms yet, but there are 4 properties here that some of them are just easier to know than to work with, but we'll go through them. If you have log of any legal base, now remember, my base has to be positive, not equal to 1. If I have log of any base of 1, then that's 0. That doesn't matter if I have log base 50 of 1, then that's 0. Or if I have log of 10 of 1, that's 0. Any log where your argument is 1, then that's going to be 0. The next one, and this is a really, really important one, says that if I have log base b of b equals 1. Now that doesn't mean a lot, but here's what it's saying in simple terms. If I have log base 5 of 5, in other words, my base and my argument are alike, then what that's going to equal to is the exponent of that argument, which in this case is 1. Now I'm going to move right along to this example 3, because here's where it makes sense to you. If I have a log of any base of an argument that's the same as the base raised to some power, then that's going to equal that power. So here's where you're going to use this. If I ask you what the log base 4 of 4 to the 25th is, you don't have to worry about that, because your base and your argument are alike, so that's equal 25. If I have log base 94 of 94 raised to the 63rd power, that's an awful looking problem, but as long as my base and my argument are the same, then my exponent is the result. Now, that little rule, number 2 and 3, are going to be really used as we begin working with logarithms. There's another one that's quite related, and we'll look at this number 4. I'm going to read it bigger where you can see what I'm talking about. If I have b raised to the log bx, now notice this, I have a base b here, and then I have that raised to a power where that base is the same. Then that is going to equal this argument expression, which is x. Now let's put that in terms of numbers. If I have 2 raised to this power, let's say log base 2 of 25. Notice the base and the base are the same. My answer is 25. If I have 3 raised to the log of 3 to the x to the 5th power, my base and my base are the same, therefore my answer is x to the 5th power. Now let's take another. Let's take e. Remember, e is a number, and I raise that to a natural log. Now if you remember, a natural log always has a base e. It may not be written, but it's always there, of x squared. The base here and here are the same, therefore my answer would be what's sitting in that argument position. Now we're going to use these rules in 4.3 extensively, so look in your class notes, get out that sheet so that you can use it as a reference if you need to.